Hello and welcome back to Algebra 2 with Mr. Austin, Mr. Lambright. It's Mr. Lambright again. Today I'm going to be talking to you about literal equations, which is a fancy way of talking about solving for a particular variable in an equation that has multiple variables. If you're ready, here we go. Oh, before I go on to the next slide, here's a reminder that your notes, a copy of the notes, that is blank for you to fill out is before this video in modules on Canvas. Otherwise, you probably got a copy from me in class. So let's talk about these formulas. We know all kinds of formulas. You just got out of geometry, so you know things like area formulas, like area equals length times width. Or for a circle, area equals pi r squared. We know other formulas. I could throw out the formula for the area of a triangle. 1/2 times base times height. There are other formulas from geometry. They're not all super important for what we're going to do next. Some algebra formulas that you might remember. What about y equals mx plus b? Or a different form of a line, a standard form we call it, ax plus by equals c. There are a bunch of different formulas. These are just a handful of them. If you want to write down more that you remember, that's up to you. But we want to get an idea of what these different formulas with multiple different letters in them look like. So the idea here is that we're going to use our equation solving abilities, but instead of solving for x when x is the only letter in the equation, we're going to be solving for a letter when there are tons of other letters in the equation, basically rewriting formulas based on the letter that we want to solve for. So we're looking at this equation and they're telling us solve for r. And r is right here. Gives us a little bit of a problem because 2 pi is there too. So we got to figure out what's being done to the r. And with the letters all smashed next to each other like that, that's usually multiplication. In fact, it's always multiplication. And we need to undo that. We got to undo the multiplication, the times r. So we are going to divide by 2 pi. It was times 2 pi. Why don't we divide by 2 pi? On the right, that's going to cancel the 2 pi with the 2 pi. So we're going to have r equals c over 2 pi. Now you might be wondering, why is r on the right? Well, it started on the right. When it says solve for r, we don't have to have r on the left side. We just need it isolated. We need it alone. In middle school, when you were first solving these equations, you were talking about isolating the variable. R is the only thing on the right side. It is isolated. That is a-okay. We are done with this problem. Okay, so in this problem, we are trying to solve the perimeter formula for w, which is the width. We see the w is only in one place right here, but we have this 2L to get rid of too. So the first thing I want to do, okay, 2L is positive. I need to subtract 2L. And I need to do it from both sides of the equal sign. So I'm going to have P minus 2L equals 2W. Now take a look at that. Those letters were different letters. They're not like terms. They don't combine. I could have written negative 2L plus P if I wanted to. It wouldn't have made a difference. I just think it's a little cleaner this way, but it's a personal preference kind of thing. Then we still have a little bit of a problem because W is not isolated yet. It's still being multiplied by 2. So we need to divide by 2. It's going to cancel there. We got another problem where w is isolated on the right. And then we have p minus 2l divided by 2. Now, let's make something really clear. P minus 2l, all of it, is being divided by 2. So these two 2's do not reduce out. This is our final answer exactly the way it is right now. We have to be okay with fractions, and that's something we're going to be getting more and more comfortable with as Algebra 2 moves on. Okay, so now we've got something that we're going to see in Algebra 2 a lot. We've got an equation that is in standard form. This is, if we graphed it, it would be a line, but I can't graph it yet if I wanted to because it's not in slope-intercept form. So we are going to solve this thing for y. And to do that, the first thing I have to do is get rid of the other term first. So we are going to subtract 9x from both sides. Now, 9x is going to cancel here. We're going to have negative 4y left on the left. And then on the right, I want to get in the habit of, when I'm changing into slope-intercept form, that's y equals mx plus b. So, yeah, I could write 7 minus 9x, but when I'm graphing these, then it's going to be negative 9x plus 7, and that's going to be really important for me. Not now necessarily, but definitely later. The next thing we have to do to get y by itself is divide by negative 4. And a few things are going to happen here. 1, negative divided by negative will be positive 9/4. And then we'll have negative 7/4. This is kind of an ugly equation, and we're not even done yet because we have been asked to find the value of y when x equals negative 5. That means this is a simple substitution problem. We barely grazed the surface of these back in the 1-1-1-2 lesson, but we're going to replace x with negative 5. So we got y equals 9/4 times negative 5 over 1 minus 7/4. Why did I write that as a fraction? Because when I'm doing fractions, multiplication, I have a numerator and a denominator, and we know the denominator, when we have a constant that's not a fraction, is 1. So I'm going to multiply. I'm going to get y equals negative 45/4 minus 7/4. I have a common denominator. They're both fourths, so I can actually do negative 45 minus 7. So I'm going to bring that up here so I have room. Negative 45 minus 7 is negative 52. And negative 52 divides evenly by 4. So y equals negative 13. If we are in person, definitely want to make sure that we learn how to use the tables in our graphing calculator. That would have made this a lot easier for us. You also could have plugged in back at this step, if you were using parentheses right, plugged that into your calculator. As long as you knew the difference between the negative button and the minus button, that would have been okay too. Finally, we've got what I think is probably the hardest math concept to wrap your brain around right now. We are going to solve for y, but there are 2 of them. So I'm going to have to do some manipulating of this equation because, yeah, I can subtract xy to the right, but then y is on the left and on the right, and that doesn't isolate it. That actually separates it more. And we haven't really gone over factoring yet. It's definitely something that I would hope you remember. But let's get over the basics here. My idea here is 2y and xy are both something that's multiplied times y. So what I want to do, if they were multiplied times y already, I could undo that. It's like undistributing. So if I was thinking about it like distributing, y would be on the outside because it's the thing both 2 and x got multiplied by. And then I would have parentheses with the 2 and the x. Why would I do that? Because now I only have one y. I don't have 2 anymore, and that means I'm actually going to be able to isolate it. Can't forget that it equals 6. And let's pause here for just a second, because there are some people going, what did he just do? So let's back up one more time. I apologize if you do understand what's going on, but we're going to do it one more time. There's a y here, and there's a y here. And it's 2 times y, it's x times y. With the distributive property, I know that I can multiply 2 things by the same thing, which in this case would be y, and that's how it would end up looking like it did in the original question stem. So instead of distributing, I undistributed. I took it back. I undid the multiplying by y, and that meant I only have one y all combined down in this equation. So now that I have these parentheses, I can actually divide by 2 plus x. 2 plus x is one thing. And then I'm going to do the same thing on the right side. So it's gone here. Y is the only thing left on the left. Then we have 6 over 2 plus x on the right. That's not a fun equation. We're going to learn how to graph those equations sometime in the future. Maybe not even this course. But something that we do need to do is finish the problem, because it says find what y equals when x equals negative 3. So instead of x, we're plugging in negative 3. Y equals 6 over 2 plus negative 3. Plus negative is the same thing as just minus. So we have y equals 6 over negative 1, which means y equals negative 6. And that's our final answer. I know this problem was probably not your favorite, but if you have questions about it, you can pause, you can go back, or you can message your math teacher if you need more help with it. There is an assignment right after this video in the module. Check it out. I think this is one where you will need either a Khan Academy or an IXL account, so make sure that you follow the instructions from the beginning of the course for that. And I hope it goes well, and if not, I look forward to hearing from you so you can get some help. That's it for today. Good luck, and we'll see you again next time.